Hello friends. You might have gone through the epsilon delta definition of a limit, which is the following. For any epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. Right? So here of course x is approaching the number a and f of x is approaching the limit capital L. So yeah, we can understand this limit. It does make sense, right, that when epsilon and delta are very small, right, they're both greater than 0 and small, then x is approaching a, so basically x minus a absolute value less than delta, and fx is approaching L, because f of x minus L, the absolute value is less than epsilon. It is making sense. It is agreed that. However, why would the definition be like this? Why would it not be the other way around, like it's here? Okay, I can also say that this is also my definition. I could say that. I could say for any delta greater than 0, there exists an epsilon greater than 0 such that if the absolute value of x minus a is less than delta, then f of x minus L, the absolute value is less than epsilon. Okay, so perhaps the reason is that only this definition excludes the possibility of a discontinuous function f of x, right, and being taken as a continuous function, right, because the discontinuous function f of x as shown here should not have a limit at the point a here, right. As x goes like this is the function f of x. Okay, it's discontinuous at a. Now clearly it should not have a limit at a. So let us look at the alternate definition, right. This is the actual definition, this one. The alternate definition is here. Okay, so it says for any delta greater than 0, okay, there exists an epsilon greater than 0 such that if absolute value x minus a is less than delta, that is x is nearby a. So let's say x is here. Okay, so f of x is therefore here, right, somewhere here. That's f of x. So we can now see that x minus a, this point x minus a can be made small, right. You can keep making x minus a small, right. It's less than, like, basically what we are trying to do is absolute value x minus a less than delta, right, and delta can be made arbitrarily small. So our attempt is to make x minus a absolute value small and small and small. So like this, we are trying to make it close and close to a, right, and correspondingly fx is here now. So you see, although f of x is quite far away from an assumed limit L, it's quite far away, it's not really close, but still you can say that f of x minus L absolute value is less than some epsilon. You can always find that epsilon, right. That epsilon, for example, could be a finite number, right. You could take this to be epsilon. So even though the function is discontinuous, if you state the epsilon delta definition of the limit in this manner, it seems to work, right, because for any delta, right, this is the delta, for any delta you can find an epsilon here such that absolute value x minus a is less than delta, then absolute value fx minus L is less than epsilon. So if this definition is there, even a discontinuous function seems to have a limit L. So this is probably why the definition is not this way, it is this one, right? So let's look at the original definition. For any epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value x minus a is less than delta, then f of x minus L, the absolute value is less than epsilon. So if I look at this definition, it says for any epsilon greater than 0, it starts with the epsilon. So okay, so if I start with the epsilon, it says for any epsilon, that means I could take my epsilon very small also, right? Smaller than this gap here, right? Smaller than this gap. So what if I take a small epsilon there? Okay, it's a very small. Actually, let me take an epsilon from L, from the point L. So from L and epsilon. Okay, so by the way, I should erase the older points, right? So that it's not confusing. Okay, so I think I have erased these points now. Yeah, so I should, one second, I'll also erase the older delta points, the older x points. Okay, so yeah, looking at the new definition, for any epsilon greater than 0, take the epsilon near L. Take this epsilon. Now I can make epsilon very small. I'm starting with epsilon. Okay, so for any epsilon such that f of x minus L is less than epsilon. So for this epsilon, can I find an f of x? No, I cannot even find an f of x, because at this point f of x, I, I just cannot find an x such that f of x is there. F of x does not exist. It's a discontinuous function. Okay, so only this definition saves us from, you know, saves us from saying that a discontinuous function fx limit exists. That it saves us from claiming that even for a discontinuous function the limit exists, because for this, with this definition, you cannot take any epsilon, right? I tried taking this epsilon, but there was no f of x found for this point. Okay, so I will not be able to find a delta, and hence for the discontinuous function the limit will not exist. However, of course it will exist for any continuous function, right? So if this is a continuous function, I can always take an epsilon near L, right? Always. Such that I can always find a delta near the point A. Okay, so this is perhaps why the definition is this way, not this way. Thank you.